Hey, welcome again. My name is Dick Ha. I run the apps at Sumo Logic. Have you, just a quick show of hand, anybody has used the app catalog at Sumo Logic? Great, thank you very much. And I have our talk today is about building a data warehouse with Sumo Logic and serverless computing. My partner in crime today is Angad.
Hey guys, my name is Angad. I'm one of the product managers at Sumo Logic, and I manage the log search area of the product. So if you have any questions relating to log searching, or you want to know what's in it, what are we coming up in the future, then please feel free to check in. All right. So before we even begin, I wanted to capture the essence of the importance of data in today's world. And I was looking through multiple quotes on the internet to find something that is suitable. I found one which was in God we trust, but everybody else must bring data. I thought that was not appropriate, so I made my own twist of things. I think it's a bit funny. I don't here to hurt somebody's religious sentiments, so apologies if I did that. But just wanted to start off in a light mood. So basically in this session, we want to cover three main things. The first thing is why business intelligence is important, why do we need BI, how can it help your organization. The second one is once you've understood the importance of building a BI platform, a BI warehouse, then how do you go and build it if you are on a budget, right? If you don't have enough resources to dedicate an entire team to this, then how do you do it in a cost-efficient manner? And the third thing is we're going to give some examples from our own experience at Sumo in building this warehouse, how we were able to generate insights that helped us and probably helping you guys. You've heard some announcement today in Ramin's keynote, and some of them were powered by our BI engine, and I'll cover them in more detail later on in the session. So the first one is why do we need business intelligence? And the first and the most important thing is for business to gain understanding of what's going on. If you're in a product org, you want to know how your product is doing, you can't really get an in-depth understanding without looking at your data. So we at Sumo Logic build adoption dashboards to track some of this stuff. But if you're not using data, then you would lose out on key performance indicators that customers are showing it to you in your data, but you are not able to find it out. The other, and it does not apply to your product organization, it applies to marketing, sales, and all the other departments. If you are running a marketing campaign, you would like to track how it is doing. And again, data can help you answer those decisions. If you are introducing a new process inside your sales organization, then again, you can find out the impact that process is having by looking at the data and then making modifications if required along the way. The second thing that you can do with data is make better decisions, accelerate the decision-making process and make better decisions. So I'll take example again from the product organization because I'm a PM. You can figure out what features to build by looking at how customers are using your product. We at Sumo Logic do it all the time. We look at how customers are using different areas of the product and then figure out how do we make them better. We also use them sometimes to make prioritization decisions. If we have 4 features that we want to work on, but we have only time to deal with one feature, then which one should we pick? We generally try and use data to back those decisions. So these are some of the things that you can do with if you have access to all of this data. So like I said, we at Sumo Logic collect data from a lot of different sources. We have our product data within Sumo Logic. We collect sales data for Salesforce. We have our customer support data, the ticketing data in Zendesk, and a lot of other places. And we try and use that data to make our business decisions. But one of the problems that we were facing was that each of these sources is a disparate source. So in order to query source and pull the data out and do analytics, you would need to know that source. You need to know how to pull that data, and that required some sort of a technical expertise. But a lot of the people who want to do this analysis, people like myself in the product organizations, don't have that in-depth technical knowledge to query data from all of these disparate sources. And correlation also becomes really hard in that case. If I want to correlate, let's say, my product data with data from my Salesforce to find out how my product adoption is affecting my overall ARR, I can't do it because I need to learn a lot of coding in order to correlate these data sources, join them together, and do the type of analysis. So what we wanted to do at Sumo was bring all of the data sources into one place, what we call as the Sumo BI warehouse. And from that BI warehouse, that's a single point from where product organization, the marketing organization, sales, everybody inside Sumo who needs access to the data can use it from one single location. So it's just one table you query and you get all the information that you need. So it's relatively simple. I can know how to query one or two tables within a BI warehouse rather than knowing how to pull data from Salesforce, pull data from Zendesk, and all these other disparate sources. Right? So I think we should now, you would have a question that how did we build this data warehouse? And I would like to pass it along to Duke, who will go through the journey of how we built this data warehouse internally at Sumo, what sort of technologies did we use, what sort of decisions did we imply. So with that, I'll hand it over to Duke.
Thank you. So let's take a step back. What are the challenges? What are the things that you should be aware of when you start to build a data warehouse? Well, like you said, because we have to deal with multiple sources, it means that we have to deal with different formats, deal with local files, some static databases, APIs, sometimes even you have to scrape some website and so on. Then all the data from these different sources has to be organized, standardized into some standard format. Usually, the data is organized along some subject. Could be customer, could be product, right? And then, usually they also timestamp properly, and you would have to run ad hoc queries and so on. The data volume usually significant. Although, compared to the traditional OM2P, you probably have to deal with fewer users. As for the ETL process, which is for extract, transform, and load, make no mistake, there would be human errors, there would be code bug, there would be oh crap moments. But it's fine, it's part of the process. So for us, what are the data sources that we use? First, we have a lot of live statics data. This is very similar to the data volume you see. We know we have the global view of how much data you guys sending, how many bytes, and there are what kind of 5 metadata sources like collectors, source path, and so on. So all of that we get. We also look into the client IPs. We know where you guys sending what IP from, which turn out to be very useful because we can correlate with our threat intel or the IP that AWS or Azure publish, so you know probably the deployment, the cloud that you are on. For data storage, we use Redshift, and you can see from here is the schema of one of the main tables that we have, where the key is the org ID, the deployment, and there's a bunch of other fields. There are 2 fields I want to point out is the query start and sys date. And the query start is the date when the data was actually generated versus the sys date is when the data was retrieved. It is very similar to, for message time, you have message time versus receive time. Why are they useful? They're useful for us to handle all crap moments, recollection and reanalysis very effectively. With that, this is our architecture. So there are 2 parts over here. The right-hand side is the monitoring component, and the GIS on the left-hand side. They're actually more than that, but you can see that at the center, we have Amazon Redshift as our core database. At the 4 corners, there are 4 representative flows, and in each flow, you will see there's a cluster of Lambda functions that read from some source, do some processing, and then finally send data to Firehose. Now, the data from Firehose finally, and is taken care by Firehose, will be sent to Redshift and also back up into S3. So why do we go with these choices? First of all, we have a small team. We don't want to deal with managing servers and so on. So Lambda offers a lot of advantage over setup, test, and run ad hoc executions. We started off with a very nimble team. I am a part-time developer. He's a part-time PM/analyst. We have a boss, but because we are part-time, he cannot be full-time, so he's also half-time. For Redshift, it's a columnar database, and it's designed for a very large data set. The thing with columnar database is that you can easily add a column without affecting the current data, which in our case happened to be very useful because one technology that we later on want to discover, we just add one column. And we also find out that if you index the field properly in the table, the performance is quite satisfactory. And as with database, we can decouple the data curation processing with visualization, which God will cover more. The last two, Firehose and S3, if you could probably play with that, is standard for archiving and such. Firehose, it provides integration with Redshift and S3 automatically for us. And we don't have to deal with breaking up the flow. So let's go into some tips when we set up this process. The first one is our serverless is on AWS. And the thing with AWS is you should start off with role. Role would simplify a lot of things as your flow would have to deal with different components. When it comes to role, there are two things that you just have to remember. One is permission and policy. The other thing is a trusted relationship. For Redshift, we found it's pretty simple. It only needs to read from S3. For Lambda, because it deals with all the Lambda functions, you need more permissions, invocation of Lambda, some basic execution. Now we also deal with some other services, so we have some permission on KMS, which is for managing key and sensitive information, Firehose and S3. And of course for relationship, Lambda, you got to trust Lambda. And then we also add two more later, EC2 and ECS tasks. I cover more on that later. We also set up two for almost everything. For functions, we have two versions over there. Of course, you know that Lambda, if you play with that, it also supports version, but we found that it's cleaner and safer to have two separate functions, one for production and one for staging. Redshift, you can use two different clusters. We just use the same cluster, but different tables with the same schema. Kinesis Firehose, we actually have multiple, because one Firehose can only send to one Redshift table. And then S3, you can use the same bucket, but we use different prefixes. When it comes to design Lambda, there are some good practice that we learned. First one is you should decouple configuration and execution code. Should leverage configuration either in a separate place or in environment variables, which turn out to be very useful later on. You should also design your function to run for ad hoc time periods and scale if need to. For example, you can see a payload from here where this function basically runs some query on Sumo, do some processing, and then send to Firehose. There's a query there. There's a time from and to period, and the design so that it can break this up into smaller invocation one day each, because this query can take a long time to run. You also design the function for different invocation types: cell invocation, manual, and event-based. The manual one happens to be very useful if you need to do reprocessing or backfilling data. Event-based is for scheduling. All outflows run on a daily basis. The last tip is, once you have multiple configuration snippets like that, it's good to have some sort of orchestrator functions that ingest the payload and then invoke other functions that actually handle the work. Now, the upside of that is, like Angad, he's very well versed in query Sumo. He can just come up with a query language and add into a config file, and the flow just pick up from there. So is Lambda perfect? No. Lambda has two major issues. Execution time, only up to 5 minutes. And it also have a limit on the payload on the Lambda. Now you got to be very mindful of the execution time, because after 10 minutes, the function would time out. You have 3 retries for Lambda, right? But the downside is that you may re-ingest or duplicate data over there. So be mindful of that. how do we overcome execution time here? The first trick is simply bump the max memory. Turns out to be pretty effective because the CPU is relatively assigned by Lambda to the memory that you give. The downside is it costs more money, but for me it's okay. I did not have to pay for it. My boss did. But in all seriousness, it was something that we also be mindful of. And at the end of the day, there's still a limit. So the next trick is to self-invoke your functions, divide and conquer, break up the payload that you have to do, and then pass it on to the next run. The caveat is there's a limit of 128 kilobytes for Lambda invoke payload. Which takes me to the next technique is when you hit that limit, breaking up the whole payload into different messages and send it to SQS and have some consumer function to read from that SQS. For SQS, there's a limit of 256 too, so just be mindful of that. But normally, in our case, when we send to it, this is more than enough once we have to use the SQS trick. For Lambda deployment, there's some, it's still primitive, right? And so as with the IDE, you can use a console first, it's fine. You can also use API. We use some tool called Cloud9, also integrated with AWS. It lets you sync different functions and then also check the code into GitHub. And then we'll also look into the CI/CD with the SAM model for Lambda. So here's the bonus. What if all the tricks that you did not resolve the time limit? Dockerize it. So the upside of Dockerize is you don't have to worry about execution, like I said, and it can still be serverless. We don't want to manage any server, like I said. ECS provide two options for you. You have an EC2 instance to backup, or you can run with Fargate. Fargate, absolutely no EC2 instance. It would spin up and then shut down after it's done. We would only recommend this when you already your flow is kind of settled because there's some overhead on setting up and building image and push it up. How easy to package? It turned out to be actually pretty easy. I was surprised when we did this. You can mostly reuse all the functions. What you need to do is to write a simple Lambda simulator to simulate the Lambda service. Now, if you follow the best practice, decouple configuration and code, then this thing can be done easily. Environment and scheduling is already supported by ECS. The last thing is role. This is where the last two roles I mentioned, ECS and EC2, come into the picture. All we did was just adding this trusted relationship into the role in order to go with ECS. So I post some of the core components of what we do over here, and it has an example of the policies, some Sumo query function, and then how we package that with a Docker file over here. So now you have some cool looking flow. Is that it? No, first of all, you have to make sure that your flow works. In our case, we find out that between Firehose and Redshift, there could be kinks. When you import, Firehose basically try to import data from S3 into Kinesis, and usually there could be errors when some fields doesn't match. So there's a log console that you can log into, and it's pretty easy to resolve. Pay attention to it. The other thing is for your infrastructure, you would have multiple flow, so you got to monitor all of that, and of course, we use Sumo. So in our function, we just print the status freely and verbosely, and then aggregate with Sumo. For logs, it's very easy to collect. All the functions Lambda go into CloudWatch logs, which can be collected with another function. ECS log also go into CloudWatch log if you use Fargate. If you use EC2, simply just use our Sumo Docker collector. So here is a dashboard that we use internally to monitor the status. You can see that I have something that we look into timeouts basically. Now that you have a working function, what are you going to do with data? Angad, could you tell us?
Thank you, Duke. So Duke covered how do we get data, how do we build the warehouse, how do we get data in. So now I'm going to talk about the good stuff. How do you start analyzing this data to make meaningful inferences and have analytics done on top of it? So we use a couple of different things in-house, a lot of different tools, you name it, and we use it internally. I personally use 5 of these, and I will cover those in more detail. The first one is Tableau. We use Tableau for quick data analysis and data visualization. I personally think it's a very powerful tool. It's very easy to get set up. Like it's all UI based, so you just it's all click and drop sort of a capability. So you should be up and running with Tableau in a couple of days. Like I think I learned how to use Tableau in a couple of days as well. It was fairly intuitive to use. It has a great selection of visualizations. They can do complex visualizations, 2-dimensional, 3-dimensional, 4 or 5-dimensional in some cases as well, which is great way of representing your data to the management level or business level executives so that they can understand what's the significance of the data. It also supports querying data from multiple different sources. If you have CSV files, JSON files, that's easy for Tableau to do. But if you have specific sort of databases, like in this case, we have a Redshift databases, then they have custom integrations. You just provide your user credentials and you're in that system. So they have integrations for almost all of the databases that I know of. So it's very easy to get data out. And then what you can also do is create dynamic dashboards that have filter conditions that users can specify. So they are sort of like, they're in one respect interactive websites that users can interact with. Let's say that I want to present sales data, so I can give a filter that allows users to narrow down sales by regions, East Coast, West Coast, Midwest, etc. Right? So Tableau really allows you to build those dynamic filters easily and put those filters in dashboards so that users can interact with it. But those are the good sides. So one of the biggest downside of Tableau, it's super expensive. Even for people who want to view this data, you need to give them a license. And I think it costs like $15 or something, even for a viewing license. So it can get pretty expensive if you have a huge organization where a lot of people want access to the data. So that's one consideration. The other one is because some of the basic sort of capability of Tableau is done in their desktop versions, if you are planning on querying super large data sets, then it would be sluggish in a lot of these use cases. So I would not recommend, if you have like, let's say, 5 or 6 gigabytes of data that you want to process, like 100 million records or something like of that order, then Tableau would probably fail on you because you have the desktop version, which is like the main source of building that data. There is an online version too. We tried out for some time, but we didn't have a lot of use case, so we didn't use it for that long. So I don't know if that has the same sort of limitation or not, but the desktop one crashes pretty soon. And one tip that I would like to give here is, if you are using Tableau for analysis, then instead of selecting tables, so you can select, if you point it to a database, you can select an individual table that you want to get data from. You can join data sets together. But those queries are really inefficient sometimes. So if you want to get real performance out of it, then I would recommend you writing your custom SQLs that does all the join operation up front. It helps get a lot of speed into your Tableau analysis. It makes the visualizations analysis quite snazzy. We also tried to use QuickSight basically as a Tableau replacement. Like I said, Tableau was very expensive, so we want to scale it and give access to it for our entire Sumo organization. So we thought Tableau will be very expensive, so we wanted to look for alternatives. So we looked at QuickSight. On the face, when we looked at it, it looked promising. It was inexpensive, easy to use, great number of visualizations, same user interface as Tableau. You can click here and there and then get the visualizations done. But once we started building stuff, we started to uncover like the real problems with QuickSight. In our experience, it was very buggy. I would create visualization one day, come back the other day, data has changed, I make some changes, and my visualization would just disappear. I have to rebuild the entire thing to get it started. Sometimes the filter conditions would just fail all of a sudden. In some cases, when I was querying like super huge data sets, it would just crash, it would just give up. And that was the most surprising thing, because this is a SaaS-based service, so I was expecting it to scale up with the load that we put on this service, but apparently it was not able to catch up to the load that we had. And we have like a couple of 100 million records, not that significant. So we are not using it anymore, at least I am not using it anymore. I also used personally SQLWorkbench. This is for very basic data validations. When Duke was building the data warehouse, I was going into the warehouse and then doing some quick sanity checks if the data is correct, everything is in order. And it's hard to do it in like different tools like Tableau or QuickSight, and it's very easy to just run a bunch of SQLs and do it in SQLWorkbench. I think the promise with this tool is I don't have to store my, I don't have to do it on a terminal. So every time you do it on a terminal, you have to log in, you have to remember your password and all that stuff. This stores your login credentials and everything in one place. It stores your query histories as well. And the best thing that I liked was you can, with click of a button, you can export the data into CSV or JSON format and bring it into another software of your choice to analyze it further if you want to, which is kind of hard if you run SQLs on a terminal. The only drawbacks of this, I would say, is you need to know SQL. I don't know if it's a drawback or not, but more business-centric users within an organization might have trouble who don't know how to use SQL, and it doesn't have a UI. We also use R a lot. We use it for our advanced analytics stuff. So we do some predictive analytics, some machine learning on the data that we get, and for that we use R. It's a very powerful tool. It's free to use. It's super fast. And we found that there is like extensive community of people who develop libraries and packages that support like any use case that you would have. If you want to build a linear regression model, a logistic regression model, decision trees, neural networks, you have libraries out there that you can leverage. Even for visualizations, they're like ggplot2 is one of the libraries that you could use for doing visualizations. Even for ETL processing, they have a couple of different packages like dplyr and tider that could help you clean up data very quickly. So it's like a one-stop shop for your data analytics need. But just like SQL, it has a huge learning curve. You need to learn how to use R in order to get the insights. But once you're up and running with it, it's a good tool to have in your arsenal. I personally use it all the time. And the last one was Sumo Logic that we use for some of our data analysis. And we had one specific use case in mind. What we wanted to do was we wanted to take a dashboard that we built out of our data and then embed it within our website so that other users like yourselves could consume it. Now, QuickSight does not support embedding your dashboards as iframe or something else. Tableau, at least the version that we had, not the online version, does not support it. I'm pretty confident that Tableau Online also has some limitations because they have a per license model to access the data. So those were not turning out to be great solutions for us. So what we did was we at Sumo have this capability of sharing public dashboards, which are publicly accessible for anybody. So we leverage that capability, and those dashboards can be embedded as iframe objects within your web pages. So we leverage that capability to embed some of our dashboard content on our websites. You will see a glimpse of some of that later on tomorrow when Bruno and Christian talk about that in their keynote. Basically, it's an online version of State of Modern App Report that you have, that you got when you registered. So we have an online version as well, and that is basically powered by Sumo dashboards, and there we use it. The only drawback of using Sumo in this particular use case is that you would need to build some of these custom integrations. Sumo does not allow you to it is not built for the use case where you pull data from Redshift and show it in a dashboard. We are primarily a logs aggregation engine, and we are doing a couple of other things. But that use case, if you have to support that, you'd have to build a custom script like Duke did in this case. It's a matter of a couple of minutes, but that could be annoying for some of the business level users who can't build those scripts up. Okay, so let's get to the good stuff. So what did we get out of this warehouse? Like, what sort of insights were we be able to generate? So the first one is, all of you have gotten a copy of this, is the State of Modern Apps report. So this is built this year entirely out of our BI warehouse. And our goal was basically, like every year, we want to help our customers make technology decisions by leveraging the understanding we have based on the collaborative community that we have built, right? And we also get another benefit out of the State of Modern Apps report. It helps guide our product decisions. Duke in the apps team knows what apps to develop based on what services you guys are using, what logs you guys are ingesting. So it helps us decide our product execution strategy as well. So that's a Sumo specific goal as well. So what we did this year was different. So we have been publishing this report for the last 2 years. In the last 2 years, we had to manually get the data out of Sumo, munge it, do some ETL processing, and then publish the report. This year, we pushed everything into the data warehouse, and there were a lot of benefits of that. The first one being, earlier it used to take us like 3 to 4 weeks to get all the data for the report out. That was a time-consuming task. Now it's like matter of clicking a button, and basically you can have State of Modern App report anytime you want. The second one was, every year we get a request of adding new data sources. We added a couple of new data sources this year. We added the CI/CD pipeline adoption this year, a couple of things around security as well. And this request comes in all the time. And to able to see the trends of new technology was a very manual and a tedious task. But with the data warehouse, it's quick and easy. Duke showed you the config file. You just basically plug in a new query there, and boom, you can start getting data, adoption data of that particular technology into the modern app report. Another benefits, I think Duke briefly touched upon that, is it helps reduce human error. Whenever you pull in manual data, you do manual analysis and you pull this data in, you have a chance that you will create some human error. And with this BI pipeline, we just have to wet the BI pipeline once. And once it is wetted, we know that all the data that you're seeing is accurate and consistent, and we don't have to go over backwards in validating all the analysis that we present to you guys. And the last and the final great thing about having a BI warehouse is comparison trends. So State of Modern App report, if you looked at it, it compares last year's data with this year's data. But you can't do fine-grained comparisons as month-over-month adoption or week-over-week adoptions. But with the new website that we're going to launch, you will be able to do those types of analysis as well. Like how Lambda has been trending over time, week over week, month over month, and stuff like that. So that is all powered by our BI warehouse. The second sort of use case I want to talk to about is understanding user behavior, how users are using our product. We wanted to understand how you guys use Sumo. That helps us make product decisions, that helps us create better products for you guys. So what we did was one of the teams here at Sumo Logic, they took some of the product adoption statistics, some of them are listed here, and try to basically cluster user behavior into different groups. And what we found was we have primarily 3 groups of users that are using Sumo. The first one, what we call as infrequent entrees. These are users who do not own a lot of content in Sumo. They don't log in too much. They only log in when there is a problem, there is an outage or some issue, and they want to come into Sumo and help troubleshoot that issue. So they are like, I would say, less pro users of Sumo, or like basic users of Sumo who use it once in every week or so. Then there are entrees who use the product more frequently, own a bit more content, and gain more value out of these. These are your SRE engineers, DevSecOps engineers who used to monitor their live applications using Sumo. So they are looking at dashboards, searches every day to see what's going on in their infrastructure and logging into Sumo every day. And then there's a third group of people here. I see a couple of Melindas here in my audience as well. These are power users of Sumo. They help create content. They create dashboards. They create searches. They help other teams build the content that they want. And they enable all the Andres and infrequent Andres in getting insights from Sumo, in basically enabling Sumo within their organizations. So this was really helpful for us in understanding what sort of user base is using Sumo and helps us make some of the product-specific decisions. And this was all powered by the BI warehouse as well. So basically, we have 3 takeaways for this session. One, I hope you guys understand the importance of BI and how it helps improve the visibility into your businesses and accelerate decision-making process. The second one is using Sumo and Serverless to build data warehouse can be very cost-effective, especially for smaller organizations who don't have huge budget to set up a new team to do this. And the third one is, I think Duke iterated a couple of times, there are a lot of decisions that you will not make upfront. There are a lot of things that will go wrong when you're building this data warehouse. So keep iterating on it, keep learning from your mistakes and improving upon your design. And with that, we can end the session. Thank you.
Well, thank you. We can take some questions if anybody has any question.
So Andres are basically, it's a code name for users who generate less content, but basically use Sumo Logic more frequently. I can look at you guys and figure out who's Andre and who's Melinda, but I don't have that information right now.
No question.
No.
Good.
Thank you. Thanks, Angad and Duke.
Thank you.
Thank you.
Thank you.
Thank you, everyone.